Hello and welcome to your Functional Skills lecture on Learning Outcome 22. Calculate values of angles and or coordinates with 2D and 3D shapes. In this lesson, you should be able to calculate values of angles, and that includes understanding different types of angles and be able to plot coordinates on a grid. So first, we're going to have a look at plotting some coordinates and making sure that you understand that. Okay, so first of all then, what I'd like you to do is pause the video and have a go at writing out as many of these coordinates as you can. So if you want to label them a certain way, you can do, but try and think about how many of these you can label, and then I'll put the answers on. Okay, if you've paused the video and had a go at that, here are the answers. Now, I know some of them, they're like a little bit, they're not perfectly placed, but I'm sure you've got the majority of them correct. Now, we need to make sure that we understand the axes here. So, I'm just going to explain a little bit about coordinates. If we look at this coordinate just here, -4, 3, okay, we have to say the x coordinate first, and x is always the first coordinate, okay? So this is our x-axis, and this is our y-axis. So that means that 3 is the y coordinate. And that's the same for every single coordinate on here. Okay, x is always first, y is always second. This will help you later on in the lesson. Okay, x, y, x, y. I'm going to label them all because I want to. All right, so x, y. Okay, so let's just start labelling a few points then. So first of all, let's label this point up here. Okay, this one. Now, what you need to do is you need to remember that we have to go across the landing. I'm going to write this here. Across the landing to write down your x coordinate, and then up or down the stairs to write your y coordinate. Okay, so we start at 0, 0. I know there's a point going through that, but that's fine. We start at 0, 0, and we go through all the way to the line where the point is sitting. Okay, this point is sitting at 3. All right, because if we go up to the point, it's actually on 3. So our x coordinate is 3. And then if we go up the stairs, we can see that it's sitting on 4 on the y-axis. Okay, so our x coordinate is 3, our y coordinate is 4. And you'll notice that everything in this quadrant has got a positive. Everything is positive in this quadrant, okay? Because we only have positive x values and positive y values going up there. All right. Okay, let's label this point down here. Okay. We're going to go across the landing. It's sitting on -2, so -2. And then down the stairs this time. So if we're going down the stairs, you can see that it sits on -2. Okay, so x is -2 and y is -2. You will also notice that everything in this quadrant is negative, because we have all negative x coordinates and all negative y coordinates. Okay? Right, let's just label a couple more then. So why don't we label this one just here? Okay. Again, across the landing, so we start at 0, 0, across to -2, and up. So across to -2, that means our x coordinate is -2, and up the stairs, which means y is sitting on, all the way up there. Y is sitting at 2. So x is -2, y is 2. Now you will notice that in this quadrant, we have positive y coordinates, but we have negative x coordinates, okay? And that's because you're going up the y-axis, but you're actually going backwards into the x-axis, so you have negative x coordinates. You don't really have to remember these, I'm just explaining it so that when you come to plotting coordinates, you find it easier. Right, finally, let's plot this coordinate down here. So again, we go across the landing till we get to the point, and the point is sitting on 3. And then down, and we can see that it's sitting at -2. So x is 3, y is -2. And again, you will notice that this one's the opposite of the other one, and you will have a negative y axis, negative y coordinate, and a positive x axis, x coordinate, sorry. Okay, so you just need to remember the rule. We go across the landing and write down the x coordinate, and then we go up or down the stairs to write down the y coordinate. It's very important that you remember that this is always x, this is always y. Try not to write them the wrong way round. Okay, people lose valuable marks by just writing things the wrong way round. Right, so let's move on to classifying angles. Now then, angles are measured in units called degrees. The symbol is a small raised circle, like that one. Okay, so when we measure an angle, it is measured in degrees. Here's a few different types of angles that you need to know. You need to know the acute angle, the obtuse angle, the reflex angle, and the right angle. Now, an acute angle is greater than 0 but less than 90. We remember that one because it's small, okay? It's small, so we call it cute to remind us that it's acute, okay? Acute angle. It's smaller than 90. An obtuse angle is greater than 90 degrees but less than 180. So that's a bigger angle. That's called obtuse. Sometimes I remember that using this word, obese, because it means bigger. All right, so you can use that there. Again, it's up to you how you remember these, but this is how I've remembered them over the years. A reflex angle is greater than 180 but less than 360. So your reflex angle makes it go all the way around like this. Okay, so you can remember that like a reflex, like your elbow has a reflex if you hit it on the funny bone. And then your right angle is exactly 90 degrees, which is what this little corner shows, okay? Okie dokie, so those are your 4 main types of angle that you must know off by heart. The rest of the angles you will need to measure. You measure the size of an angle using a protractor. You need to make sure that the cross on the protractor is on the angle, and that the baseline on the protractor is on one arm of the angle. You need to read the angle from the scale that starts at 0. So for this angle, I'm going to show you, here's the angle, and you're going to be asked to measure this part here, okay? So I'm going to take my protractor and place it on top of the angle. Can you see that where it says, make sure the cross is on the angle? Okay, make sure the cross is on the angle. The cross is here, look, right on the angle. The cross of the protractor is just there. It's right on that point where I said we're going to measure. And the protractor itself, the 0 part, is starting from the flat line. Okay, can you see that? Just rub that out again. So the 0 part is here. We always measure from 0. Okay, we're not going to measure from 180, are we, and start and go round and call it 30 degrees. Why would we do that? We have to measure from 0. So measuring from 0 and going all the way round to here, and it gives us 150 degrees. So the angle is 150 degrees. Hopefully you're going to get used to measuring angles, and you're going to get yourself a protractor, and you're going to be able to do this on a regular basis. So, angle facts then. We've got a few facts that we need to know. Whenever lines meet or intersect, the angles they form follow certain rules. So, any angles on a straight line add up to 180 degrees. So, you can see this straight line here. We've got A, B and C. And even though it's been cut down here and here, it's still on the straight line. So all 3 of these angles always add up to 180 degrees. So you must remember that. All angles on a straight line add up to 180 degrees. angles in a triangle add up to 180 degrees as well. Okay, so all of these three angles here, they would all add up to 180 degrees. So whatever those angles were actually labelled in terms of numbers, they would add up to 180. Angles in a quadrilateral add up to 360 degrees. So whatever these would be labelled in terms of numbers would add up to 360 degrees. Okay, so it's good to remember these, because obviously you'll have to use these facts when answering certain questions later. So they add up to 360 degrees in a four-sided shape. Remember, a quadrilateral is four-sided shape. Angles around a point add up to 360 degrees. Okay, so all of these lines here that meet in the middle and the angles that they create all add up to 360 degrees as well. All right, so you can remember these two add up to 180 and these two add up to 360. It's very, very important to remember these. It will make your life a lot easier if you remember them. Okay, so a few more rules then. We also need to remember that vertically opposite angles, so this is formed when two straight lines cross like this. Okay, vertically opposite angles are equal. Okay, so this one is the same as this one, and this one is the same as this one. Okay. We can also remember, if I just grab a different colour, the straight line rule, because this is a straight line, which means that these two add up to 180 degrees. And this is a straight line, which means that these two add up to 180 degrees. Okay? So just remember those straight line rules, okay, as well. But for this one, if they cross over, this angle equals that angle and that angle equals that angle. We say that vertically opposite angles are equal. Okay, you need to remember that. Now then, an exterior angle of a triangle is equal to the sum of the two opposite interior angles. Okay, so what we can say is that these two interior angles here, what this means is these two angles are the same as C. So if we add those two together, it tells us what C is. And that's the external angle of the triangle. However, another thing we could remember here is that this is also a straight line, so D and C, let's write this down here, equals 180 degrees as well. All right, so just the extra rule is an exterior angle of a triangle is equal to the sum of the two opposite interior angles. That just means that these two added together make this one here, this C. Okay, I'm just giving you that extra rule just because. Now then, we also need to be able to label angles in triangles. When labelling a general triangle, the side opposite the vertex A is called little a. So the vertex, remember, you should know this because we went through it, is the corner. We did a video on this. So here's an example. All right, showing you this one. So here you've got side, the vertex A, the corner, and the opposite side is A. The vertex B, opposite side is B. The vertex C, opposite side is C. So you've got to be able to understand that the angles are capitals. Angles equals capitals. Okay, the vertexes, the corners are capitals, and the sides are lowercase letters. Okay, small letters, lowercase letters. Okay, so just remember it like that. Then you also need to be able to say which angle is which. So there are different ways of identifying an angle. Okay, so if we look at this angle here that's measured 30 degrees, we would call that angle ABC, because it's the angle in the, we're labelling the angle at B. Okay, it's 30 degrees. ABC equals 30 degrees. If this one and this one were labelled, so these would be, I'm just going to mark these as 75 degrees each. If I wanted to label this angle here, C, I would call that ACB, because C is the angle I'm trying to find, or trying to label. Oops, 75%, 75 degrees. Okay, 75 degrees. Okay, and then if we're labelling A, we could call that BAC, because we're labelling angle A, which is also 75 degrees. All right, so if they're asking you about an angle and they say, work out the angle BAC, they basically want you to work out what is the size of the angle at A. Okay, so what's this angle going to be? All right, and it equals 75 degrees because I've told you. All right, so that's how you remember, or you identify which angle it is they're talking about in the question. Right, so after giving you a few facts, I would like you to pause the video and have a go at answering these questions. Okay, so if you've had a go, let's go through these then. The first one, what is angle A? Well, we should know that this is a straight line. So it adds up to 180 degrees. Okay, so I need to do 180, take away 135, and it will give me the size of my angle, which is 45 degrees. Okay. For this one, we've got angles around a point. Angles around a point add up to 360 degrees. This angle here is 90 degrees because it's got a little corner. So if I do 120 plus 90, okay, that's 210. And to work out this last bit, I just need to do 360, take away 210, okay? So, I mean, it's not too difficult to work this one out. If I take away 200, it leaves me with 160. And if I take away the 10, it leaves me with 150. So that one should be 150 degrees. All right. And then we have this one here. It's telling us that these two sides are the same, which means these two angles will be the same. A triangle adds up to 180 degrees. Well, we already know this top angle here, okay? So if I do 180, take away 80, it leaves me with 100 degrees. So A plus A equals 100 degrees. And all I need to do is half it, because they're both the same. So A equals 50 degrees. All right, not too bad at all, hey? Last one seems a little bit tricky, okay, because you've got two angles to find. Remember, this is a straight line first of all, and a straight line adds up to 180. If I do 180, take away 110, okay, that leaves me with 70 degrees. So A equals 70 degrees. And then, because I know that that's now 70, if I replace that with 70 degrees, okay, I now know that my triangle adds to 180. So to find B, if I do 70 plus 40, which makes 110, okay, then 180 minus 110 gives me 70 again. So B must be 70 as well. Okay, so B is also 70 degrees. The other thing that you could do in order to check is just think, okay, well, I'm just going to double check that inside my triangle adds up to 180. So I can do 70 plus 70 plus 40. Well, two 70s are 140, and if I add another 40 to that, it gives me 180. So I know I've worked them out correctly. Okay? Okay, so looking at some angles in parallel lines then. There are three types of relationship which are produced when a transversal crosses a pair of parallel lines. And what that means is, a transversal just means that a line goes through a pair of parallel lines, okay? So the first one is that alternate angles are equal. So can you see these are my parallel lines? One just there and one just there. And this line has crossed through them. Okay, so I'm not going to keep that on there. I just wanted to point it out that they're my parallels. And when that line crosses through them, we can see that we have this Z shape forming here. Okay, we can call that a Z angle. But in your exam, if you're asked about it, it's an alternate angle. Alternate angles are equal, okay? So, we can't say Z angle, but it can remind us that alternate angles are the same. So this angle will be the same as this angle. It creates a Z shape. And we can remind ourselves by calling it the Z angle. Another one is corresponding angles are equal. So you can see here, we kind of create this F shape, but it's the angle above. So I don't want you to get confused by that. So it creates this F shape, but we've got one on the inside of the parallel lines and one on the outside of the parallel lines, okay? We can call that an F angle. But they are also equal. So whatever B is, this would also be the same, okay? But it's one on the inside of the parallel lines and one on the outside. Okay, so that you must remember that. One inside, one outside. And they are the same. They're equal. Now, also, you can remember that allied or co-interior angles add up to 180 degrees. Now, this creates a C shape, kind of. Okay, a C shape, so we can call that a C angle. But we must remember that it's allied or co-interior angles. And they add to 180 degrees. Okay, they're not equal. Sorry if I said that. They add to 180. So they are both on the inside. Okay, both inside here. I can't write. Both inside. And they add to 180 degrees. Okay, so that's the three types of angle that you need to remember when dealing with parallel lines. Now you can use these relationships to find the value of some unknown angles. Okay, so here's an example. I mean, if you'd like to pause the video and have a go at working out X, Y, and Z, then feel free to do so. Okay, if you've had a go. Now, X must be 130 degrees because it creates that Z angle. It's backwards, but it's still a Z look. Okay, so this 130 and this X here are going to be the same. So X must be 130. Y must be 50 degrees because we've got 50 degrees there and the vertically opposite angle to it is the same. And then Z must also be 130 because it's vertically opposite this one here. And vertically opposite angles are the same. Okay, why don't you pause the video and have a go at working out A, B, C, and D. Okay, if you've had a go. A must equal 120. Okay, so we can still use angles on a straight line here. So we know that those two angles add up to 180. So 120 plus 60 makes 180. So A must be 120 degrees. B must be 60 degrees because it's vertically opposite this one. And then, if we look very closely, C must also be 60 degrees because it joins this F shape with the C. It makes this Z shape with the 60. And that is an alternate or corresponding angle. Okay, a Z angle. And then because D is vertically opposite C, that must also be 60. So they're both 60 degrees. Okay, I hope that is making sense to you. All right. It's just getting practice and making sure that you remember. So the more of these that you do, the better you'll get. Now then, another thing you need to know is angles in polygons. A regular polygon has all sides equal and all angles equal. So for example, like a regular pentagon, I won't be able to draw it because I'm not very good, but a regular pentagon has 5 sides and all sides will be the same. Okay, and all angles will be the same. That's how it works on regular shapes. Okay. Now, a polygon has interior and exterior angles. An exterior angle is formed when a side of the polygon is extended outside of the shape. So, here is a polygon. This angle here is the interior angle because it's inside the shape. If we look, this is the actual shape. Just draw that in there so you can see. That's the actual shape. And then these are our extended lines, which then create the exterior angles. Okay, exterior angles can be, as long as they're extended, they create an exterior angle. So this is the exterior angle just there. Okay, this is also an exterior angle, so is this. We could also have one there, we can have one there. It doesn't matter, okay, they're just extended lines, not there. Okay, so where they're extended, where they're sticking out, we have an exterior angle. Sorry, it is there because we've extended there. Okay, so we can have one here. We can have one here. It just creates an exterior angle when we extend the line, the shape of the line of the shape, rather. Okay, so we're just going to go through some exam questions then now that will possibly come up, and so it will give you a really good idea of how to tackle these. Now, this question, first of all, is asking you to work out the size of angle Y in this polygon. Now, this is a 6-sided shape, and usually I'm going to say it's a regular polygon, okay? So I know it doesn't look like it, I've not drawn it very well, but it's a regular 6-sided shape, regular hexagon, okay? Now, here's a table just to quickly explain a few things to you. In a 4-sided shape, in a quadrilateral, okay, you get 360 degrees. The sum of all of the angles equals 360 degrees. In a 5-sided shape, it's 540 degrees. In a 6-sided shape, it's 720 degrees. And in a 7-sided shape, it's 900 degrees. Now, all you do is, because you should be able to remember this one, okay, 4-sided is 360 degrees. We've talked about that a lot. You're just going to add 180 degrees every time to get to the next shape. So then if you're given, say, a 10-sided shape, you can add 180 to get an 8-sided shape, add 180 to get a 9-sided shape, and then add 180 to get a 10-sided shape. Okay? So at least then you can work it out. Now, this question is asking you to work out the size of angle Y. And all you need to do, I mean, if you want to pause the video now and have a go at that, then please go ahead and do so. Okay, if you've done that, then all you need to do is do 126 plus 79 plus 138 plus 145 plus 83 plus Y. And because it's a 6-sided shape, that's going to be equal to 720 degrees. Okay? Now then, depending on whether this comes up on your calculator section or your non-calculator section, usually something like this will come up on your calculator section. So you should be able to use your calculator to add up all of those numbers, okay? So I know that all of these numbers added together equals 571. So 571 plus Y equals 720. And then all you need to do to work out y is take away 571 from 720. So I can write that there if I want to. And that will give us y equals 149 degrees. And that's it, you've worked it out. Okay, not too difficult, I hope. So you just make it all equal to 720. We just didn't know what y was, and we worked backwards in order to find out. You'll see that this comes up quite a bit as well on like expressions and equations and things like that, and we're working out values. Okay? All right then, let's move on to another question. So this is one from a functional skills test. It says that archaeologists study human history by digging up and analysing items from the past. Chen is a volunteer with a community archaeology group. At the weekends, she helps to dig at an archaeological site. The volunteers have to record exactly where each item is found. They do this by using a coordinate grid laid over a map of the site. The volunteers have found the wall of a building. It runs in a straight line from -25, 100 to 150, -75. Draw the position of the wall on the grid. So feel free to pause the video and have a go at that one, and then press play and I'll go through the answer. Okay, so this is taking us back to the beginning of the lesson where we looked at coordinates and plotting them. So you should find this one fairly easy. It says it runs in a straight line from -125, which is here, 100, which is here. So we have to mark on the grid there. Okay, -125, 100. Remember, we always go along the x-axis first and then the y. So we're going to go across to -125, up to 100. The next one says to 150 -75. So we go from 0 again and we go along to 150 and then down to -75, which is there. So we've plotted those 2 points, and then what we're going to do is you would draw a line going to those 2 points. You would obviously use a ruler. Okay, I just haven't got one on here. Okay, and you've drawn the wall. It says draw the position of the wall on the grid. All right, all done. Now then, the next question also uses this grid, so we'll have to come back to it, but let's have a look. It says there is another way that the volunteers can record the position of an object. Measure the object's distance from a fixed point and measure the angle. So the volunteers find an object at the point 100, 100 on the coordinate grid. Mark the point on the grid in 4A. So what we've got to do is just mark that point there on the grid in 4A. So we can go back here, use a different colour pen, and it's at 100, 100. Well, we go from 0 across to 100 and then up to 100, and there is the point. Okay, we can even write in 100, 100 if we want to. I know it's hard for you to do this one because obviously it's on the grid. The next part says the volunteers measure the distance of the object from the fixed point 0, 0. Then they measure the angle. It asks you to, well, it says what size is the angle. So all they want you to do is measure this angle up here. Okay, so they've measured from the fixed point to, to the position of the item up here, and this is the horizontal. It wants you to measure this angle here. So what you would do is you would get your protractor out, and what I've tried to do is I've drawn the angle out again. Obviously I've had to use the picture, so it's a bit tricky, and I've put the protractor behind it. What you would do, obviously, because your protractor would be see-through, you can put it in front of it and measure the angle. Now, what I've also done, you might not have noticed, but where I've positioned the picture is so that the angle, the point, this point here, is sitting right here on this cross section. Okay, so you'll see that my angle is going to go somewhere up here, okay? Ignore the blue line, that's just because I've had to use a certain picture of a protractor. So once I bring my angle in, it should sit right there nicely, and I should be able to measure my angle. So what I'm going to do now is I'm going to measure the angle, and I can literally draw on top of that line and see where it leads me on my protractor. Now, don't forget, and you can't see this because of the picture of the angle that I've added, there is 0 degrees, okay, which means we can measure the angle that way. And there's also 180 degrees here. So we're obviously going from 0. We have to go from 0. And we're going to go all the way up to the line that I've just drawn. Now it looks around about 35 degrees. You wouldn't be penalised if you put 36 degrees either. Okay, so you need to make sure you're practicing using your protractor. Alright, I know that's not the best way of showing you, but it's the best way that I could do it on this question now. So you can then say that your answer here was 36 degrees or 35 degrees. Okay? Okay, let's just look at a couple more questions. This one says, one triangular face of a chocolate bar is shown in the diagram. Calculate the size of the angle labelled A. Now, if you'd like to pause the video and have a go at this one, you should be able to, because it's not too difficult. Okay, now then, we should be able to recognise that this triangle, remember, triangles add up to 180 degrees. And because they add up to 180 degrees, we know that those two add up to 100. 50 plus 50 equals 100 degrees. So A must then be this 80 degrees that we have left. Okay, and it's only a 1 mark question, so it wouldn't have asked you to do too much there. Okay, right then, last one. So this one says that Lottie reads that the best angle to launch a ball from a free throw is 50 degrees. Okay, it says calculate the angles A, B and C. So obviously you don't have to calculate all the angles A, B and C, because the question, oh actually we do, because it says down here, so you must have some more marks for this. I'm going to put 2 marks down here because they wouldn't ask you to do all of that. Okay, let's work out angle A then first. If you'd like to pause the video, please go ahead and press play for the answer. Okay, if you've had a go, we can see that on this first diagram, this angle here entirely is 90 degrees, because 90 degrees from there, it shows us that using that little corner. We know that this is 40 degrees. So to work out A, we just need to do 90, take away 40, leaving us with 50 degrees. Okay, so A is 50 degrees. B, now then, we should know that B is on a straight line, which means all of these together add up to 180 degrees. So 65 plus 35 equals 100 degrees. Okay, so B must be 180 minus 100, which leaves us with 80 degrees. And finally, for C, we can see that this is actually created a triangle, and it's given us these 2 measurements. So I know that a triangle adds up to 180 degrees, and I can do 65 plus 65, which is 130 degrees. So C must be 180, take away 130, so C must be 50 degrees. Okay, so B is 80, C is 50. So you've got your 2 marks down there for working those out, but then it says to tick the ones which are 50 degrees. Okay, so we can tick C and we can tick A, because A is 50 and C was 50. All right, so well done if you got those right. That's really good. And, you know, these questions are not something that you do every day, so it's hard to remember how to do different things like this. But I'm sure you're getting the hang of it really well. Just remember to practice using your protractor. I would really recommend that. Okay, so hopefully you feel confident calculating values of angles and coordinates within 2D and 3D shapes. So well done throughout that lesson, and I look forward to seeing how you do on your assignments.